Do you feel the vibes?
Okay, so we're going to talk about function operations and composite functions. So if you have two functions, f of x and g of x, and if you want to add the two functions, f of x plus g of x, one way to write that is f plus g of x, like this. Okay? Or if you want to do f of x minus g of x, in more concise form, you can do f minus g of x. Same with f times g of x and division. Okay, so here we have f and g. Why don't we do these four operations for all of these? So let's do f of x plus g of x, right? That's going to be f plus g of x. Right here. So number one, f plus g of x, right? That's the notation. It's going to be x squared minus 2x plus 3x minus 4. So it's x squared plus x minus 4. It also says to state the domain of each new function. And so the domain of this new function will be what? Exactly. It's a polynomial function, all real numbers. All right, so number two, f minus g of x. So I got x squared minus 2x minus, in parentheses, g of x, 3x minus 4. So this is x squared minus 2x minus 3x plus 4. X squared minus 5x plus 4 is f minus g of x. And what's the domain of that? You can't simplify it further. And also a domain of all real numbers, right? Okay, so number three, f times g of x. It's going to be the first binomial, x squared minus 2x times 3x minus 4. So that's 3x cubed minus 4x squared minus 6x squared plus 8x. So here we have 3x cubed minus 10x squared plus 8x. Right? And what's the domain there? All real numbers. Okay. Nothing too exciting here. F over g of x is x squared minus 2x over 3x minus 4. Okay, here. If you can factor anything out and then cancel things out, you must do that and simplify. But if when you factor things out, you can't cancel anything further, then it's not necessary to even factor, right? So you could just leave it the way it is. So that's it. We're done here. The domain, though, it's everything except for 4 over 3. So it's negative infinity to 4/3 union 4 over 3 to infinity. Okay? Easy as pie. Okay, composition of functions. You remember f of g of x, when you can take a function and, insert it into another, right? It's a composition. They're like nested functions. F of g of x. And so another way of writing that is, f of g of x like this, right? So it's, equivalent notations. All right, so here we go. for each pair of functions, let's find f of g of x, g of f of x, and then f of g of 2. Okay, so first we're going to find f of g of x. So the notation here is really the same. All right, so f of g of x, we're going to take g of x and insert it into f. So it's going to be 2 times x plus 3 squared minus 1. Correct? So that is 2 times x squared plus 6x plus 9 minus 1, 2x squared plus 12x plus 18 minus 1, so that's 17 actually. Right? That's f of g of x. Questions? Okay. Next, let's do g of f of x. Now, I want to take f of x and insert it into g. So that's going to be 2x squared minus 1 plus 3. So this is g of f of x equal to 2x squared plus 2. Any questions? Okay, now let's go to f of g of 2. Okay, so f of g of 2, if you've already, okay, so there are 2 ways. One way, okay, yes, you can take 2 and plug it into f of g of x. But notice, if let's say, if it wasn't f of g of 2, if it was like f of g of some higher number, that's a pain in the neck to put it in that quadratic function. But there is another way of doing it, right? If you have f of g of 2, you can actually start from the inside. What's g of 2? 5. Then if you go outside, what's f of 5? 2 times 25 minus 1, 49. Right? So much quicker. Yeah. That's like so efficient. Wowzer is right. Yeah. Yeah. Okay? I mean, you could also do, 2 times 2 squared plus 12 times 2 plus 17, but I mean, not as much fun.
Does that kind of depend on specific functions, though, whether it's more efficient to just put it into one function or the other function?
I mean, I guess, but it's also, yeah, but it's very rare that the composite function is simpler than this, Yeah. Let's do another one. Okay, f of g of x. Okay, so f of g of x, like this, right? So, okay, so let's square this, x squared minus 2x plus 1 minus 1. Ooh, fun. So f of g of x will be the square root of x squared minus 2x. Fabulous. Okay, g of f of x oh my god. Okay, so the square, okay, so g of f of x is this, parentheses, and then the square root of x minus 1 minus 1 squared. Oh my god, look at how fun this is going to be right now. You got to square this now, okay? So remember, squaring a binomial, you got to square the first term, You got to square the last term, and in the middle, it's first times second times 2. Remember? Okay, so let's do this. Square the first term, x minus 1. Square the last term, plus 1. And in the middle, what do you get? 2 times negative 1 times this. So negative 2 root x minus 1. Oh my God, how much fun was that? My God. Oh my God. So g of f of x. Oh geez. Oh boy. These go away. X minus 2 root x minus 1. Wow. 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 Holy guacamole. Only way to put it. Okay. So now f of g of 2. So g of 2, how much? 1. Is that right?
Wait, so I can do this right. I don't think it equals thing either. I'm just explaining this after trying to work.
Yeah. So what's f of 2? Oh, f of 1. 0. Okay. So one thing we need to do in calculus is kind of the opposite of this. Do you see how here we are putting one function inside another? In calculus, we kind of have to decompose functions, and you'll be given a complex function, and you have to decompose it. You have to separate the two functions that make it up. So basically what you have to do is we say you have to find an inner and an outer function, right? So you have to find two functions f and g such that h is, f of g. So for example, suppose h is 3x minus 1 squared. Then you see how like the outside function is something squared? So that f of x would be x squared. And then if you zoom in, the inside function is 3x minus 1. Okay, so look at this one. H of x is this. So what would you say the outer function f of x is?
1 over x squared.
1 over x squared. And what would be the inner function? X plus 2. Fabulous. So here, this is h of x. What would you say is the outer function f of x? Minus 3. Correct. And then what would you say is g of x? The inside, 5x minus 2. This is very, very important in calculus. Plus 2. If you've heard the chain rule, this is the beginning of it.
Wait. How is it? It's not.
What's the change rule?
I heard chain rules are really not fun.
Huh?
Chain rule is like when you're taking the derivative of a polynomial in parentheses squared.
We literally had a whole lesson in my English class about using smaller words.
I told you.
Yeah.
I don't remember how to do it.
Eli's living life backwards.
Yeah, like with the.
Like that movie, what is it? The Case of Benjamin Button or something? Is it that? The Curious Case of Benjamin Button? It's from my time. Fine, whatever. It's for old people.
Wasn't that the person who like
It's Brad Pitt. Yeah, that's what I'm saying. Thank you. Welcome to the party.
It's a disease.
Yeah, no, I know what you're talking about.
What disease?
No, but she like aged backwards.
They don't actually age backwards.
Okay, so now I'm actually going to do example 4 first, then go on to example. Okay, so f plus g of 0. So this is your mine. No, I'm charged. I'm charging. F of 0 plus g of 0. So where is f of 0? So f is the blue. F of 0 is negative 4. Okay, fine. What's g of 0? Negative 6. So this is negative 12. Easy enough. So now this is f of g of negative 4, right? So again, we start from the inside. So what's g of negative 4? Negative 4. And then, so what's f of negative 4? Also negative 4. Yay! Okay? All right. So let's take a look at this now. Let's talk about the behavior of this function as x approaches 0. So what we have here is 1 minus 1 over x. Okay, 1 minus 1 over x. So let's just talk about f of x equals 1 over x first. What happens to 1 over x?
1 over x is a thing.
Okay, what happens to the limit of 1 over x as x approaches 0? So let's think about this. As x approaches 0, there is an asymptote. So now, as this denominator becomes really, really small, what happens to the fraction? Let's see. If you have 1 over 10, how much is that? 0.1. 1 over 1, 1. 1 over 0.1, 10. 1 over 0.01, 100. 1 over 0.01001, 1,000. So as this denominator gets really, really big, the whole thing, as this denominator gets really, really small, the whole fraction becomes huge. Okay, but, listen, but the limit as x approaches 0 is actually dne, because from one side it goes to positive infinity, from the other side it goes to negative infinity. So this is dne. Now in this case, this is the limit as x approaches 0, 1 minus 1 over x. So from on the one hand, it will be like negative, as x approaches 0 of this function. On the one hand, it's 1 minus infinity. On the other hand, it's 1 minus positive infinity. On the one hand, it's 1 plus. On the one hand, it's 1 minus negative infinity, or 1 minus positive infinity. Still, it's dne. Okay? No. Listen. No. Listen. It approaches 2 values. So listen. 1 over x. From one side, it goes up to the positives. From the other side, it goes down to the positives. It's the same with 1 minus that. From the one side, it's positive. From the other side, it's negative. So this is dne. Yeah.
So, like, if we're talking about continuity, would it be like infinite?
Infinite, yes, infinite discontinuity. Okay? So now this one. The limit as x approaches infinity, 1 minus 1 over x. So what happens to this as x approaches infinity? It approaches 0. So if this approaches 0, what's 1 minus that? 1. So this whole thing would be 1. Okay? And there you have it. Okay.